Hi, ladies and gentlemen. This is Mr. Green, and this is another in my lessons on pre-cal. I cannot be with you today because I am in Dallas at a teacher development meeting. So I'm recording this to send it to you in advance so that you know what's going on and you can work through some issues. Remember, 28 days after assignments are due, they are locked down. So we're not to that point as of yet, but you do not want to have zeros out in the grade book, especially zeros that get to that 28-day point. So you want to make certain you get them made up as quickly as you possibly can. Okay? So having said that, let's move on. We are looking at Unit 1 and we're dealing with some issues that we need to make certain we understand how to do. If an angle measures pi over 7 inch radians in, I'm sorry, pi over 7 in radians, what's the measure of the degree? Well, there's an easy conversion factor. Radians to degrees, you multiply by 180 over pi. Why? Because it's 180 degrees in a pi, in one pi of a radian. So when we multiply by 180 and the pi's cancel each other out, you're left with 180 divided by 7, or 25.7. Now I'm going to take this opportunity and go ahead and convert it into minutes and seconds too. If I just take the last two decimals there, 0.71 times 60, I get 42.6. If I take that 0.6 times 60, I get 36. So you could either say 25.71 degrees or 25 degrees, 42 minutes, and 36 seconds. Okay? And that's the easy way of converting minutes to seconds and radians and so forth. It's all just one big conversion factor that we're doing here. Okay? So the radian measure of an angle is 95 degrees, 3 minutes, and 55 seconds. So we want to get that in pi. So what are we going to do? First thing I'm going to do is I'm going to take 95 plus 3 minutes times 60 times 60 minutes in every minute, or 60 minutes in every degree. Golly, get that right, Mr. Green. And then plus 55 divided by 3600. Why did I get 3600? Because there's 60 seconds in a minute and 60 minutes in a degree. So I have to divide by 3600. When I do this, I get 95.065. Well, I want to express that in radians, so what I have to do is multiply times pi over 180. So when I divide 95.65 by 180 and multiply it times 3.14, I get 1.658, or 1.66 would be the answer that I would come up with. Now, how did I know to go ahead and multiply by 3.14 here? Because the word approximated by told me that they wanted the approximate answer. They didn't want the exact answer. If I was looking for an exact answer, I wouldn't have multiplied it times the pi. I would have left it in 95.65 divided by 180, and that would have been my answer with the term pi sitting there. Okay? So that would have been something like 0.5 or something like that. It's real close to 1/2. But that's what I would have left it in if they wanted the exact answer. But the approximate answer told me they wanted me to multiply it times 3.14. Okay, you've got an arc corresponding to a central angle of 38 degrees. What does this mean? You've got a circle, okay, and it's got an arc of 38 degrees. Well, remember, we got our base angle here and our angle that goes up like this. So this angle is 38 degrees. It's got a radius of 20 feet. And they want me to find how long that arc is. Okay? Well, we've got a formula for calculating the circumference of a circle. It's 2 pi r. And when we multiply it times the number of degrees divided by 360, or 20 times 2, which is 40 times 38. Well, 40 times 38 is 1520. Divided by 360 is 4.22. And then when I multiply 4.22 times pi, I get 13.36. I want you to note, I carried the pi as if it were a variable all the way through here to the very end. And then at the very last second, I multiplied 4.22 times 3.14 to get this number here. I didn't multiply the 3.14 any earlier. That would have caused rounding errors earlier in the problem. So you don't multiply it out until you get to the very end. Okay, Here we've got a circle with the theta degrees. If the arc length that's shown here is 35 degrees, I'm going to try and sketch it with my pencil here. They're saying that what I've got here in black is 35 inches. And then they want to know what the theta is in radians. Well, the formula for calculating the circumference of a circle for a particular arc in radians is you simply take r times the number of radians. So if we divide by r, 35 divided by 15, that'll tell us how many radians it is. So it's 2.33. Now if I go ahead and stick 3.14 in there and divide that out, I get 0.74 pi. So this might be a little bit closer answer. This is the answer that they wanted in the place I took this off of. So 2.33 radians. Okay. If a point is located at negative 12 over 13 comma y, and that lies on the unit circle, what does that mean? Well, we've got a circle that's got a radius of 1, right? And they're saying that at negative 12 over 13, well, I'm going to throw my little x and y axis in here. Negative 12 would be this direction over 13. 12 13ths, that's not very high up on the circle, is it? Negative 12 over 13, that's almost 1. So it's going to be right out in here. Okay? And they're wanting to know what is the coordinate of the second coordinate, the y. Well, we can look at this as a Pythagorean theorem problem, right? We can find this x value here simply by knowing that this value out here, this x is negative 12 over 13. The y value is what we're trying to find, and we know this one is 1. So I'm going to stick this in there and say the x squared plus negative 12 over 13 squared. I didn't get those out as squareds. Those are supposed to be squareds, and that's supposed to be 1 squared. So this is equal to x squared is equal to 0.479. How did I get that? I took 1 minus 12 over 13 squared, and that gave me that 0.179. And when I take the square root of that, I'm sorry, yeah, it's squared. When I take the square root of that, I get the 38.46. Converting that to a fraction, I get 5 over 13. So that's what this y value is 5 over 13. Okay? Cool. You guys see what I did there? Okay. Moving forward. On the unit circle, we have the coordinates of the terminal point is located at 19 over 3. Well, once again, unit circle, radius equals 1, and we got our baseline here. So if I go around the circle once, that's 2 pi. If I go around the circle twice, that's 4 pi. If I go around the circle a third time, that's 6 pi. 19 divided by 3 is 6 1/3 pi. So we're looking at something like that theta right there. Okay? So it's in this positive and positive values over here. So I'm going to take the sine of theta, and I wrote there 1/3 pi. I wrote 1/3 pi there, but that could still be 19 over pi. It doesn't matter. I mean, the 2 pi is just going to cancel itself out. And as a matter of fact, I would like to show that to you on the calculator. So if I come over here to the calculator, I got to make certain it's set up in the right mode. So I'm looking, it's set up in radians. Good. So we're in good shape there. And then I'm going to take the cosine of 19, and I'm going to stick pi in there, divided by 3. And when I hit enter on that, I get 0.5. And when I take the sine of 19 pi divided by 3, I'm going to get 0.8666666. Wow. So we actually found the values that we could use there. Now, if you really wanted to do this in a different way, if you know that the x value is at 1/2, right here, this x value is at 1/2 by using the cosine, you can say that 1/2 squared plus the y value squared will be equal to 1 squared, and you can take that y squared is going to be equal to 3 over 4, and take the square root of it, and you get that y is equal to the square root of 3 divided by 2. You know what? You figure this out, it's going to be 0.866. That's another way of doing that one. Cool? Cool. So, this has been the Class Connect. Typically, I'd go a little bit slower and I would be asking questions of you and see if I couldn't get responses. So that's why it's not taking very much time. My secret word for today is plywood. So, you have to send me a K-mail with the word plywood and the fact that you're in pre-cal, and I will give you credit for having attended the class. Okay? I do appreciate the fact that every time you send me things, you are telling me that you're in pre-cal. It really helps me understand and answer certain questions for you. Okay, so I look forward to seeing you next week, and I don't think I'll be having anything keeping me from being in Class Connect next week. Talk to you later. Bye.